All right, so now to take things a little bit further, right, we can talk about mass of a compound, right? So we have this formula mass and we have molecular mass. So the only difference between this and when we were talking about carbon before is that instead of just talking about the average carbon atom having a mass of 12.01 AMU, now we're talking about a compound that has more than one atom in it, right? For formula mass, I should be talking about an ionic compound like sodium chloride, salt. So if I was going to consider salt and try and come up with its mass, I would just add up the pieces, right? On my periodic table, sodium is 22.99 and chlorine is 35.45 AMU. So if I add those things together, I get a 58.44 AMU. So if I have a compound instead of just a given element, all I do is add up the pieces, right? And it's not going to matter if it's an ionic compound like sodium chloride or if it's a molecular compound. If it has covalent bonds in it, it should be the same thing when it's all said and done. So an example of a molecule, a compound that exists as a molecule, and it's a covalent compound, water, right? All I have to do is add up the pieces to figure out its mass. So I have two hydrogens, which actually is 2.02, plus 16 for an oxygen. Its mass is 18.02 AMU, right? But again, that actually isn't all that useful because there's obviously a lot of water molecules in even a very small sample of water, right? Molar that mole concept, that 6.022 times 10 to the 23rd, right, is not as big as you think it is. A mole of water is barely a sip of water. Right? There's so many molecules in that sample that it's almost unimaginable, right? So this one water molecule is really, really small. I don't really care about that mass. What I care about is that molar mass again. So the formula and molecular masses were both in AMU, but the molar masses would be exactly the same. They'd just be in grams. So for salt, I'd still have the 58.44, but now I have a gram value because I'm talking about 1 mole of that substance, right, of sodium chloride, right? And again, that 18.02 for water, that's going to be grams in 1 mole of that substance of water, which again is how I can relate that so easily. Remember, the density of water is 1 gram per milliliter. So 18.02 grams is 18.02 milliliters, right? Roughly 20 milliliters. That is less than a big mouthful of water, right? And that's 6.022 times 10 to the 23rd molecules. But this is what we're going to use because we can actually measure it, right? Those AMU units are not all that useful in the lab.